good use of the time. So today we'll be finishing the part for our midterm exam. We'll be having the midterm exam next week at the exact same place and the exact same time slot. So the exam will be 3 hours long. I'll post the detailed information about the exam later, maybe later today or tomorrow or by tomorrow. So I'll first, I'll briefly talk about what the exam format and also the requirements will be like. You guys are allowed to bring a cheat sheet, 大抄, A4 double-sided with anything you like on it. You can write as many things as you like. But a general suggestion is that I would ask you guys to write it yourself or type it yourself, not just copy and not just do a lot of like screenshot of all the slides and make them very small and put it on the A4 page. I actually don't recommend that way. Some people just like to do it that way, but if you do so, then usually you don't really like go through the contents yourself. So a general suggestion is that I think you should write or type it yourself so that the process of creating the cheat sheet itself can serve as a preparation for you. You guys are also allowed to bring a calculator to the exam, and any kind of calculators are allowed. It could be a financial calculator, very basic ones, or even like the engineering calculators. Anything you like, you can just bring it here as long as you find it helpful. And the exam will be, I think, consists of true or false questions, some true or false questions, some multiple choice questions, and also some numerical answering questions, short answer questions. I think that will be what you need to know before the exam. It will cover from the beginning, chapter 1 to chapter 7, where we end today. And there's also a second assignment that will be due, I think, on Sunday, right? The day before until October 23rd. Yeah, Sunday this week, next week, right before the exams. So you can use it as a preparation. Someone just told me that the first assignment was locked, so I just unlocked it. It was locked. It wasn't my purpose to lock the exams, the assignments. So you can use it as a review, check it yourself, read the questions, and check if you already understand how to do these problems. The exam will mostly be composed of questions that comes out from the slides, where the exercise we go through during the class, and also from the assignments. Mostly it will be questions from these places. Most of the questions will be basic and straightforward questions. So as long as you paid enough efforts, I think you will get a reasonably good grade. And also someone asked me if I can post the Excel files that I used during the class to demonstrate some of the calculations, and that I did. I actually did so. So I posted the spreadsheet for chapter 4, chapter 5, and also chapter 6 and 7 that we will be doing today. So that's basically what you need to know for the class and also for the exams. Let's quickly go through what we have been doing on chapter 6 last 2 weeks ago, and then we'll finish the rest of it in the first class. So what is chapter 6 about? Chapter 6 is basically about interest rate futures. Again, still this is about futures and options class. So the main focus was on futures and forwards for the first half of the class. But to show you guys like some of the details, we first talk about the convention about day counts for fixed income assets like treasury bonds, treasury bills, treasury notes. What do we mean by day counts? Basically, that's how we are able to talk about what is the cash price that we consider the part of the accrued interest. And then we talk about some of the conventions for different type of instruments, usually classified by their time to maturities. Then we talk about the idea about quotations. Quotations is very important because quotations is what you see when your broker provides you information about products that you may be interested in buying or selling. So we talk about the quotations for treasury bills and also treasury bonds. After we go through the idea about quotations and cash prices and also the conventions about day counts, we finally reach to the part where we discuss about interest rate futures. What is interest rate futures? Basically, they are futures for the above and also other interest rate assets. Like we could have a futures on treasury bonds, ultra treasury bonds, or 10-year treasury notes, 5-year, 2-year treasury notes, or like the short-term horizons, 30-day Fed funds rates. Basically, we are agreeing to exchange these long-term assets or short-term interest rate exchanges in some predetermined future periods. Then we talk about the idea about conversion factors. What does it mean? Why do we need to care about conversion factors? It's because usually, like you take, like for example, let's take a look at this table once again. These futures are, the underlying of these futures are usually very loosely defined, like ultra T-bound futures, but ultra T-bound can be any kind of bond that has a maturity longer than 25 years. Treasury bond futures, we basically just know that treasury bond means very long-term treasury bonds, usually US government bonds with a maturity longer than 15 years, but shorter than 25 years. So what is that bond the short side needs to deliver by the time the contract, the futures contract terminated or matured? That is up to the short side's decisions. So because of the fact that these underlines are very loosely defined, it creates some rooms for the short sides to decide what is the best option for he or she to deliver during the through this futures contracts. That's a reason why exchanges actually provide an information that's called conversion factors. What is conversion factor? Conversion factor is an idea, a notion that is special for each different treasury bonds or each different bonds. For each bond, there is a conversion factors. And the idea is that usually the higher the traded price, the transaction price, there's a higher conversion factors. So the rule is that the cash price received by the short side is calculated as the most recent settlement price. Basically, that's the settlement price for the futures transactions, multiplied by the conversion factor of the bond that the short side decided to deliver, and also plus some of the accrued interest, which is something tedious, but also we need to take care of. So then we have some questions that talks about what is the best option for the short side to do. Because think about a scenario where the short side reaches the maturity and need to pass through some bonds to the long side through the futures contract. Suppose that the short side doesn't have any bonds, he or she needs to first buy some bonds from the spot market and then deliver the bond to the long side through the futures contracts. So here comes some decisions that he or she, the short side, needs to think about. He or she needs to first purchase some bond right away and then deliver it. And from the quoted bond price, you can calculate what is the spot price of these bonds that the short side buy immediately. And then with this conversion factors and also information about settlement prices, you're able to calculate what is the cash price the short side will receive through the deliveries. And then based on all the options, the short side can decide what's the cheapest way for he or she to deliver the bonds. This is one of the first important concepts in chapter 6. Then we also talk about, is it possible for us to do treasury bond future pricing? As we mentioned, so we have a very naive and straightforward examples in chapter 5, where we basically just exclude the present value of the coming incomes and then throw it to the futures to decide what is the price for the futures. But now when we are there to consider about a lot of detailed information about futures contracts, then it's actually quite hard to price a futures contract because we do not know what is the cheapest to delivery bond is, and we do not know what is the exact delivery dates. Are there any kind of date count conventions that we need to care about? That's the problem that exists when we are to do evaluations. So in these kind of questions, basically we have to make some assumptions. Like this example, we assume that we know what is the cheapest to deliver bond, know exactly what is the time horizon it is paying the coupons. If that's the case, then we can do a pricing for the treasury bond futures exactly in the same way as we did in chapter 5. And then lastly, we talk about some of the important but also straightforward short-term interest rate futures. The most popular ones before, still traded nowadays, but probably will be terminated in the near future, is the Eurodollar futures. It's called Eurodollar futures, but indeed it's the LIBOR rate on US dollars. The reason why it's called Eurodollar futures is basically because it comes from LIBOR, and LIBOR was something European. That's why it's called Eurodollar futures. But yeah, just remember we're still talking about US dollars. Eurodollar future is a 3-month LIBOR rate futures, and the idea is that a basis point change corresponds to a $25 price change to one contract. Why was that the case? It's because each contract is defined on $1 million notion principal, and then it's a 3 months interest rate. So $1 million multiplied by 0.0001 and divided by 4 gives us $25. When there's an increase of 1% in the 1 basis points in the LIBOR rates, at the loan side, we actually experience a loss of $25. If it's an increase, then let me correct myself. Yeah, I think I got it right. Yeah. When there's an increase 1 basis points in the interest rate, in the LIBOR rate, the loan side will lose and the short side will gain $25 per contract. It's also the case when we are talking about situations where interest rate decreases. Okay, so that's the idea about Eurodollar futures. This is one of the demonstrations. I think it's better to go through this demonstration once again so that you guys, I can help you guys review about what is this instrument about. So Eurodollar futures, let's take a look. So this is actually a scenario where we hypothesize that could happen according to the table, according to the originated from this table. This is a table, again, on May 21st, 2020. On May 21st, 2020, let's take a look at the Eurodollar futures. Again, it's said that the contract is on a $1 million principal. Assume that we're thinking about scenarios where standing on May 21st, and we are thinking about any kind of investments or borrowing or lending behaviors that would take place on September. So we want through a 3 month horizon from September to December. Let's take a look at this product. What does this product mean? It means that standing at May 21st to have some projections about what the 3 months LIBOR rate is on September. According to the most recent transaction, said that the quotation was 99.72. So again, what is the quotation rule for these short-term interest rate futures? Basically, they're quoted as 1 minus R. So this 99.72 basically says that standing at the time point of May 2020, people on the market collectively think that a 3 month LIBOR rate from September 2020 to December 2020 should be 28 basis points. 100 minus 99.72 give us a 0.28. It means 0.28% or 28 basis points. So that's what people's projection about the 3 months LIBOR rate should be, standing at the time period of May. And because this is a futures contract, people can be trading, buying, selling, longing, shorting anytime from this period and before it's matured or before the termination of the contracts. Gradually, like we learned in chapter 3 or chapter 2, I think we know that when the time to maturity is about to expire, the spot rate will be, the spot price will be very close to the futures price will be extremely close to the spot price, because if it doesn't hold, then there will be arbitrage opportunities. So it appears that on September 14th, this September 2020 Eurodollar futures has a quoted price of 99.81. It basically tells us that the spot rate the 3-month LIBOR rate on September 14th is very close to 19 basis points. It turns out that there is a difference between the price that we locked on May 21st and the real 3-month LIBOR rate. And once again, something that I need to remind you guys, but is that the difference when we are talking about LIBOR, once again, we know what the rate is at this period, at the beginning of the period. So yeah, basically that's it's the nature about LIBOR. It's a forward-looking interest rate notion. So people know what LIBOR is. LIBOR was announced, the LIBOR rate was announced at the beginning of the periods. So people check up the announcements from the LIBOR, and we see that the 3-month LIBOR rate was very close to 19 basis points. That's the reason why the 3 months, the Eurodollar futures on September 14th has a value that takes a value of 99.81. So what does it mean to use the Eurodollar futures to lock into some price? Let's stand back to the time period of May 21st. If we long one contract, what does it mean? If we long one contract, then basically standing at May 21st, we lock into a LIBOR rate of 0.28 basis points or 0.28 for 3 months LIBOR rates, and $1 million multiplied by 1/4. Why 1/4? It's because it's 3 months rate multiplied by 28 basis points give us $700. It basically tells us that if we lock into a 28 basis points LIBOR rate for 3 months, we'll have a gain of $700. The interest payment will be $700. So let's think about a scenario where we long this Eurodollar futures and we close it out before September, and then we go to the spot. What would be the case? So first, if we go to the spot on September, the 3 months LIBOR rate is 19 basis points. If we have exactly $1 million, $1 million multiplied by 19 basis points multiplied by 1/4 give us $475. It's basically just that we are saving $1 million in a bank that provides LIBOR rates, 3 months LIBOR rates. We got $475 for our $1 million principals. But at the same time, because we long Eurodollar futures on May, close it out on September 14th, the interest rate decreases. The interest rate decreases and we are on the long side, so we actually experience some gain. We were locked into a payment. We're going to receive something that's higher, but then we're closing out when the payment is lower. So we actually gain 9 basis points from this contract. For each basis point, we will experience a gain of $25. So we long this Eurodollar futures, we close it out on September, we realize $225 plus $475 get us back exactly to $700 again. So that's what we mean by locking into some interest rate using a Eurodollar futures. I think I go through this example 2 weeks ago, but I hope that I can refresh your understanding once again. Anyone has any questions so far? This is what we have been going through 2 weeks ago. Yes? Why the long side gains when the interest rate decreases, right? This is your question. So why was that the case? We locked into a Eurodollar futures that promised us a 28 basis points, and we're the long side. Basically, it's not seemingly like we save $1 million, and then we are asking for a 20 basis point interest payment as an interest payment. But at the end, by the time we close, it turns out that the interest rate was 19 basis points. It's lower. So by the time we loaned the contract, we were promised was a higher interest payment, and by the time we close it out, the reality was that the interest rate was lower. So that's the reason why you got a gain from this long short process through in the futures market, in the Eurodollar futures market. Does that make sense? Cool. Any other questions? Great. So that's Eurodollar futures. Now we'll be discussing about 1 month SOFR rate futures and also 3 month SOFR rate futures. Even though I placed the 1 month SOFR rate future slide one slide ahead, I think it's easier to go through the 3 month SOFR futures first. So as we know, LIBOR will be phasing out sometime soon. It should be phased out by the end of this year, but then the US LIBOR rate will still exist till June next year. But still, yeah, it will phase out very soon. So people want to find something to replace this very popular future instruments. So here comes the 3 month SOFR futures. What is 3 month SOFR futures? It is actually an interest rate futures that is designed extremely close to the idea about LIBOR, the Eurodollar futures. It's also on 3 months interest rate, but instead of defining it on LIBOR, people now define it on the SOFR rates. And what else? Yeah, it's also on US dollars. It's just that now everything is on the SOFR rate instead of LIBOR rates. It's also on a principle of exactly $1 million, just exactly the same as Eurodollar futures. Let's take a look at this table once again. The Eurodollar futures is defined on a contract size of $1 million. The 3 months SOFR rate is also defined on the 1 million contract size. So it also implies that a 1 basis point increase in interest rate results in a $25 gain to the short side for either a Eurodollar shorter or a 3 month SOFR futures shorters. So basically, it's designed as close as possible to the Eurodollar futures. The problem is that we know the LIBOR rate at the beginning of each time periods, but we only know the SOFR rate at the end of the periods. So the real settlement will happen 3 months later than a scenario where we are longing or shorting a Eurodollar futures. That's the only big difference. We have to wait until all those overnight rates are displayed to everyone on the markets to decide what is the 3 month SOFR rate, and then to decide what is the settlement. What is the settlement? That's the idea about 3 month SOFR rate. Sorry, 3 month SOFR futures. Now let's talk about 1 month SOFR futures. 1 month SOFR futures is very similar to 30-day Fed funds rate futures. We haven't been discussing about the 30-day Fed funds rate futures just because, yeah, they're just too similar, and I think it's easier to discuss about them right here. Again, it's quoted as 1 minus R or 100 minus R, and then the R is the arithmetic average of the overnight rates. The reason why I need to emphasize the same is because we'll talk about after one slide, we'll talk about how compounding really happens for SOFR rates. This should be taught in chapter 4, but then I think it's easier to talk about it here after we go through the idea about day conventions. And yeah, so we'll see that the 1 month SOFR futures is one very big exception for the SOFR rate calculations. The reason why it's calculated as arithmetic average of overnight rate is because the 30-day Fed funds rate future is calculated this way, and similar to the relationship between the 3 month SOFR rate futures and the Eurodollar futures, the 1 month SOFR futures is also designed as close as possible to the 30-day Fed funds rate futures. Yeah, something I think I believe I've mentioned at the beginning of the class two weeks ago. You can see that even on May 21st, 2020, the 1 month SOFR rate for May 2020 is still very popularly traded. What does a 1 month SOFR future of May 2020 mean? It's actually a futures product defined on the periods for the month of May 2020, May 1st to May 31st. And even on May 21st, this product is still traded. Why was that the case? It simply just reflects the nature about SOFR rates. It has people do not know what the 1 month SOFR rate is for May, even on May 21st, because May hasn't ended yet, and there are still 9 to 10 days, probably 8 trading days. So people do not really know what the real 1 month May SOFR rate is. That's the reason why it's still traded. Okay, that's the idea. And 1 month SOFR rate and also the 30-day Fed funds rate are defined on a 5 million contract size. So just do your math, you know that 1 basis points increase or decrease corresponds to a $41.67 change per contract. Why was that the case? It's because $5 million multiplied by 1 basis points and multiplied by 1/12, because this is a 1 month rate, equals to 41.67. So if you are the long side and there's a decrease of 1 basis points for each contract, you'll be earning $41.67. Let me reiterate that once again. If you are alongside of a 1 month SOFR rate, 1 month SOFR futures, and indeed there's a decrease of 1 basis points, then for each contract you long, you will be earning a gain of $41.67. Make sense? Okay, that's the idea about 1 month and 3 month SOFR rates, and 1 month and 3 month SOFR futures. Let's now discuss about how do we compound overnight rates. This is something that we should be teaching on chapter 4, but then by then we haven't talked about the idea about day counts yet. So I think it's easier to put it here. We know that what is SOFR rates? They are overnight, secured overnight interest rate, interbank interest rate in the US. So it's super safe. Why? It's because it's 1 day secured interbank exchange rates. So it's super safe. People usually consider them as the SOFR rates as the risk-free rates. But the problem is that these are overnight rates. They are 1 day, they are interest rate only for a 1 day horizons. How do we calculate, for example, a 1 month horizon, 3 months horizon, 6 months horizon SOFR rates? The answer is also very straightforward. We basically just compound them. How do we compound them? Basically, if we want to calculate the SOFR rates between some day 1 to some day n, then basically we look up what is the day 1's SOFR rate, 1 plus day 1 SOFR rate multiplied by most likely 1/360 multiplied by 1 plus the SOFR rate on day 2 multiplied by most likely 360. Blah, 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 blah. We do the multiplication, b minus 1. And lastly, we multiply it by a fraction of 360 over d. D is the number of days from day 1 to day n. By doing so, it will be annualized figures. If you don't do so, then it will be a very large figures. You have to count. It will be a very small figures. You have to count. The reason why is because you multiply a 1/360 everywhere for the interest rates. Why do I use the word most likely? It's because there may be some days that we have to count more than 1 day. For example, the SOFR rate on Fridays. Usually SOFR rate on Fridays, it will go through Saturday and also Sunday. So it usually will be calculated as say R2, say day 2 is Friday, it's a Friday. Then R2, the Friday SOFR rate will be multiplied by 3/360 for this D2 head, because we have to count each of the dates, the real existing dates. Does that make sense? That is the idea how we compound overnight rates. For example, the 3 month SOFR rate futures, it's calculated this way. And the only exception for the overnight rate calculations is the 1 month SOFR futures. Because once again, it's like I said, it's calculated as the arithmetic mean of overnight rates within that horizons, and we do so to mimic the idea about 30-day Fed funds rates futures. Everything okay? We're almost here. We're almost there. We almost finished chapter 6. Okay. So I'll show you guys one example, the SOFR futures example. Suppose that once again on May 21st, 2020, there's an investor. He or she has agreed to pay a 3 month SOFR rate plus on $100 million of borrowing for 3 months, beginning on December 16th, 2021. 2020, that example. Yeah, I think 2021, 3 months of our rate, 2021. Yeah, that's the example. Yeah, there's no typo. Cool. So what does it mean? So it means that there's a person, he's an investor. We haven't, so for the first statement, we haven't really talked about futures, anything about futures yet. It's just that he or she will have to borrow some money on December 2021. And he or she is already negotiating as early as May 21st, 2020. He or she, yeah, let's just suppose he's a guy. He's planning to borrow some money from someone. And then they have negotiated and decided that for this 3 months borrowing, the interest rate should be the SOFR rate plus 200 basis points. Yeah, probably because there's some risk associated with this lending or borrowing. So it has to come with some spread. It could not be just borrowed or lended by the risk-free rates. So they agreed that it should be borrowed or lended for an interest rate of 3 months SOFR rate plus 2% or 200 basis points. That was the borrowings. And then now our investor, he checked up the futures markets book. He looked up the quotings and realized that standing at the time point of May 21st, wow, so he sees that the implied 3 months SOFR rate for December 2021 is actually as small as 1 basis point, 99.99. Basically, it shows that people standing at the time point of May 21st, no, like guessing there is going to be an interest rate increase at the end of 2021. So people simply think that the interest rate will be very low. They guess it will be 1 basis point or 0.01%. So our investor wants to take advantage of these quotings. That's the reason why he or she decided to, he really wants to, if it turns out that the SOFR rate is really 1 basis point, what is his borrowing cost? His borrowing cost will just be 201 basis points, right? And his borrowing cost is defined on the 3 months SOFR rate. We don't know what's the 3 months SOFR rate yet, and no one will know until February 2020. So standing at May 2020, investor has no idea what the SOFR rate is, but he sees that people on the market believe that it's most likely will be a 1 basis point SOFR rate because the futures market implied so. So he decided to take advantage of it and then started to short 100 December contracts, 2021 December contracts. He decided to short that future. By doing so, our investor can lock into a borrowing rate of 2.01%, even though we don't know what the 3 months SOFR rate would be by this time. Why is that the case? We can show you by a very straightforward demonstrations. Suppose that one, and let's discuss about 2 scenarios. The first scenario is that the SOFR rate, the 3 months SOFR rate is 0.8%. The other one is, let's make some even crazier assumptions that there's a negative interest rate. Likely, which is something possible standing at the time point of 2020. People just think that we're going to have a low interest rate world forever. So let's consider these 2 examples, and I'll show you how our investor lock into the borrowing costs. Suppose that the 3 months SOFR rate turns out to be 0.8%. Then what is the borrowing cost? This borrowing cost is SOFR rate plus 200 basis points or 2%. So if the SOFR rate is 0.8%, then his borrowing cost will be 2.8%. Then 2.8% multiplied by his $100 million multiplied rate tells us that the interest payment should be $700,000. But at the same time, our investor also short this contract, and that you know that when there's an increase in interest rate, the short, when there's an increase in the experience some gains. How much does he gain? We go from 1 basis points to 80 basis points. So there's a 79 basis point increase in the interest rate. 79 multiplied by 25 hours per contract, and then he shorted 100 contracts. At the end, he realized a gain of $19,000 and $500 for his 100 short positions. Together, he's going to pay $700,000, but he also made some gain through the futures transactions. At the end, he's paying out $502,000 and $500 collectively, and that's divided by one. That's divided by one fourth of the $100 million. It tells us that it's basically similarly like a 2.01% interest payments. That is also the case if we have a negative interest rate. If it turns out that the interest rate goes even further down to a negative 0.4%, then his borrowing cost would be 2% plus this negative 0.4%. Together, it would be a 1.6% interest payments. He has to pay his lender $100 million multiplied by 1.6% multiplied by 1/4. That's $400,000. And then that's also the case because for our investor, because he shorted 100 contracts, 3. There's a decrease from 1 basis points to a negative 40 basis points. So there's a decrease of 40 basis points multiplied by $25 per contract, multiplied by 100 contracts. He also has an additional $102,000 and also $250 payments or loss, gain or loss from the futures transactions. Together, the total payment is still $502,250. So yeah, so people can basically use these futures contracts to lock into some future interest rate, even when our borrowing or lending is defined on some reference rate that will not be realized until then. That's the idea about using the futures contracts, the interest rate futures contract, to lock into some borrowing or lendings. So far, a lot of puzzling places. Yeah, never mind. You can check it yourself. Oh yeah, one thing I'd like to mention. So I haven't seen anyone in my office hour yet. So, but yeah, you guys really enjoyed coming to me during the break times. So I would encourage you guys to utilize this the office hours, especially like this Thursday is the last office hour before the midterm exams. So I just basically sit in my office working on my own things, but then having a pandering heart. Not sure if you guys will come, and I'm still working on my own stuff, but I still feel a little bit excited about if anyone will come to me and ask me about some interesting questions about options and futures. So yeah, so I just encourage you guys to use the office hour as much as possible as you can. Okay, so that's so far futures examples. We're almost till the end of chapter 6. Let's talk about one thing that's a little bit confusing, but it's indeed a very straightforward idea. So in the old times, when we think about LIBOR rates are announced by those bankers for a 1-year horizon. You can just check what is the 3 months LIBOR rate, 6 months LIBOR rate, 1 year LIBOR rate from their announcements. And the SOFR rate is also very popularly defined on these short-term horizons. But here comes the questions. I think in chapter 4 or chapter 5, we talk about the difference between the zero rates and forward rates. Zero rates are interest rate applied for the time horizon from today to some distant future. And then the idea about forward rate is some interest rate applied to some future periods, some T1 to T2, both in the futures. So here's the questions. If we want to have some projections, forecasts about a longer horizon zero rates, how do we empirically do so? what is the way that we could able to come up with a measure for some longer horizon zero rates. Like I mentioned, if it's a 3 months LIBOR rate, 6 months LIBOR rate, 1 year LIBOR rate, they're basically just 3 months, 6 months, 1 year zero rates, right? This is the time period starting from today to 3 months in the future, 6 months in the future, 1 year in the future. The LIBOR rates are basically the zero rates, or the SOFR rate. If we want to know some zero rate for a 2-year horizon, 3-year horizon, or even like a 5-year horizon, how do we do so? The answer is that we can actually bootstrap it. I think we talked about that in chapter 4 already, but then here's a way that I can show you how we can really do a bootstrapping for a LIBOR zero. Suppose that we already know the 300-day LIBOR zero rate. Suppose it's 2.8%. It's calculated as continuously compounded. And then now we look at the 90-day forward rates in 300 rate in 300 days. It could be a 3 month LIBOR that will be taking place in some distant futures that will be, according to the book, you can see that, okay, there's a time period. Suppose it's coming in 300 days. And basically, we can do a very straightforward calculation. Do you guys remember forward rate can be calculated as R2, the zero rate from now to T2, multiplied by T2, the time periods, minus zero rate from now to time 1, multiplied by T1, divided by the difference between T2 and T1. Thought about it, you can check it yourself. I think it's chapter 4, right? And then if you rewrite it, you can rewrite it as the zero rate for time 2 can be calculated as this formula. It could be calculated as this formula. Now, according to our example, we know what is the 300-day LIBOR zero rates. We know what is the forward rates. The 90-day forward rate, according to our understanding in this chapter, you know that it basically is some futures interest rate products. Then basically we can do the calculation very straightforwardly. Interest rate multiplied by the difference between T2 and T1 plus the zero rate for time 1 multiplied by T1 divided by T2, we will be able to calculate what the zero rate for this 391-day horizon be. And now you may ask me, but Tim, you said that LIBOR rate is only available for 1 year, so how do we come up with a 300-day LIBOR rate? Then basically, you can just do it reversely. So if we suppose we have another three months LIBOR futures, 3 months euro dollar futures from in 210 days. Then you can do the same to calculate this 300-day LIBOR zero rates, and you can do it reduction fashion. And basically, when you come within a 1 year horizon, that's something you can already observe. So that's the idea about how we can extend a LIBOR zero curve. We can calculate or we can measure what a longer distance zero rate is according to the interest rate futures quotings you see from your brokers. Okay, does that make sense? Any question? We'll talk about it once again next chapter. Yeah. That's a good question. So for any kind of interest rate, any kind of reference rate, you can draw its term structure. So the curve are basically term structure is a fancier name for that curve. So term structure basically is what something goes for some across some time horizon. LIBOR can have a yield curve. SOFR can have a yield curve. Any kind of reference, not necessarily reference, any kind of rates can have a yield curve. You can even calculate or compute a yield curve for the S&P 500 and any kind of assets, financial assets. You can draw a curve, and basically that's what we mean by its term structures. So here, why do people care about a LIBOR zero curve? It's not the risk-free rate, but it's very useful practically. People use LIBOR rates to do discounting in a lot of situations. Nowadays, people are replacing LIBOR by SOFR. So yeah, SOFR will still be a very important reference rate, and people will be curious about what the term structure of SOFR rate is. The two are different by their nature. SOFR rate is closer to risk-free rate, while LIBOR rate is not. But both of the two have been and will be used a lot in a lot of situations where people will try to discount some future rates using this reference. Will I answer your question? Okay, cool. So let me very quickly talk about one last concept in this chapter, the duration-based hedging ratios. We talk about creating a hedging in chapter 3. So now, when we are there to talk about a duration-based hedge ratio, it's quite similar to what we did in chapter 3. It's just that now we're using this the instrument for us to create a hedging. It's usually the case when you have a portfolio that will be affected by interest rate. Usually, if maybe you have a bond portfolio, maybe you have some fixed income portfolio. If that's the case, you can basically use this instrument, this interest rate futures as instrument for you to create a hedging strategy. The idea is also very straightforward. Let's take a look at this one again. We have the delta VF equals to negative VF multiplied by DF. Once again, this is exactly the same thing you see on chapter 4. The part we talk about hedging. Wait, chapter 4. Yeah, that's the place where we talk about durations, right? So the change in your value of your assets equals to the value of your assets multiplied by the duration of it and multiplied by the change of interest rate. We derived this thing already in chapter 4. If you forgot about it, you can check it once again. And because these interest rate futures are also affected by the change of interest rate, so you can also write the change in the price of the interest rate future contracts equals to the contract price multiplied by the duration of this interest rate future themselves multiplied by the change in interest rate. That's the idea. And you know that what is that interest rate over here? They're basically the macro conditions, the macroeconomic conditions. That's the thing that we are afraid of, and that's the thing we want to cross out. That's the reason why you can basically divide the first equation by the second equation. The change in divide the second equation by the first equation. Yeah, that's the more straight, intuitive way of understanding. The change of your portfolio in terms of the change of the contract equals divided by the price of the contract multiplied by the duration of the contracts. So yeah, that's the reason why the optimal number of contracts required N star equals to PDP divided by VF. That's the number of contracts you need to long or short the instrument, the interest rate futures to hedge for your fixed income assets. Does that make sense? It's actually quite straightforward. So yeah, that's pretty much about it. I think you can just read the example yourself. It's super straightforward. It's an example I copied from the textbook. If you have any question, you can raise it later on. But I think it's just so straightforward that I think I can leave it to you guys. Okay. Yeah, let me just very quickly talk about it. So what is it? So basically, we talk about a scenario. You're a fund manager. You're investing in a bond portfolio, and we talk about there's a futures contracts for there's a T-bound futures. We talk about the quoting, so you know what the price is. We talk about what is your portfolio's duration. We talk about what is the T-bound contract's duration, and then basically your portfolio size divided by the contract price per contract multiplied by the duration of your portfolio divided by the duration of the contract equals to something like 79. It tells us that If you have a long position, you want to short 79 futures contract. The reason why is because when interest rate increases, your portfolio decreases in value. But at the same time, the short position in the futures contract gives you a gain. On the other way, if the interest rate decreases, your portfolio gains some value, and also your short position will have a decrease in value. By doing so, you have a delta neutral position in interest rate. That's the very straightforward idea. The numbers, you don't need to care about that very much. It just, I think the notion, the concept is actually more valuable. So that's the idea about chapter 6. We finish about chapter 6, and we'll come back and finish chapter 2 in the next 2 classes. So that's about it for chapter 6.